Imagine a future where energy is endless, clean, and almost free. No carbon emissions, no oil wars, just the energy from the stars bottled on Earth. This isn't sci-fi. It's called nuclear fusion. And the question is, can we actually do it? Fusion is nature's ultimate power move. It's what keeps stars burning for billions of years. Here's how this works. Don't worry, we'll keep it simple. You take two tiny atoms, usually hydrogen, smash them so hard they stick, and when they fuse, they form a new atom, helium. But here's the kicker. The newly formed helium weighs slightly lesser than the two hydrogen atoms combined. That missing mass, it didn't just disappear, it became energy. Thanks to Einstein's mass energy equivalence, we now know that a huge amount of energy can be created by a tiny bit of mass. This is the same process that makes our sun shine, where billions of fusion reactions happen every second producing light, heat, and life. Why is fusion such a big deal? Why are scientists chasing it like it's one piece of the energy world? Because if we can crack it, if we can build a fusion power plant, we get fuel that's practically unlimited. Just a few grams of hydrogen from seawater could power your home for years. No carbon emissions. Fusion doesn't burn anything. There's no smoke, no soot, no carbon dioxide. No dangerous waste like in nuclear fission. The leftovers don't stay radioactive for thousands of years. And mainly, there is no risk of a meltdown. If something goes wrong, fusion just stops safely because it's so hard to maintain. Fusion is like a perfect campfire. Infinite fuel, no pollution, and it just stops when you stop feeding it. That's why people call it the holy grail of energy. But if it is so perfect, why aren't we doing it now? Because it is extremely hard to do. Stars make it look easy because of their enormous gravity and endless time. Deep in the sun, heat and pressure forces hydrogen atom together like it's nature's own pressure cooker. But on Earth, we can't crush atoms with gravity, so we use heat, a lot of it. To get hydrogen atoms to fuse, you'll have to heat it over 150 million degrees Celsius. That's 10 times hotter than the core of the sun. At that high temperature, atoms turn into something called plasma. Now here's the next challenge. How do you contain something so hot? It would instantly melt through any container we have on Earth. So scientists cleverly came up with the idea of using magnetic fields to keep plasma in place. The setup is called tokamak. It's like a magnetic donut which floats plasma in air. It's basically like a mini star inside a bottle on Earth. So is this all still a pipe dream or are we getting close? The answer is, for the first time in the history, we are making real progress. In 2022, a US lab, Lawrence Livermore National Laboratory, achieved something historic. Fusion ignition. That means they got more energy out of a fusion reaction than they actually put in, just for a fraction of a second, but still a huge breakthrough. And it's not just one lab. The ITER project in France, the world's largest fusion experiment, is a $22 billion international effort to build a full-scale fusion reactor. Meanwhile, private companies are entering the race as well. Helion, a US startup, says they will deliver electricity from fusion by 2028. Commonwealth Fusion Systems, backed by Bill Gates, is developing high-temperature superconducting magnets to make smaller and cheaper reactors. For decades, fusion was always 30 years away, but for now, it feels very closer than ever. One question people always ask is that safe? Totally fair. We have heard about Chernobyl and Fukushima. But those were fission reactors, splitting atoms apart, which releases dangerous radiations and can spiral out of control. Fusion is the opposite. You are fusing atoms and the reaction itself is self-limiting. If anything goes wrong, it just stops. No chain reactions, no meltdowns, no explosions. The main technical concern here is not an explosion, it's engineering. How to handle neutron damage to the walls. How to build materials which can withstand insane conditions. How to safely contain tritium. But as far as safety goes, fusion is one of the safest power we'll ever design. Let's dream big for a moment. If fusion actually works, it could change the course of human history. We could power entire cities without polluting the air. We could generate green hydrogen for fuel. We could electrify developing nations without digging a single coal mine. Fusion might even help us reach Kardashev Type 1 civilization, a world that can harness all of its planet's energy. And beyond that, fusion reactors on Mars, Starship refueled in space, mining asteroids. Let's be real. Fusion won't fix climate change today, even if it works tomorrow. It will take years to scale up. We still need solar, wind and smarter energy systems right now, but fusion, it could be the power source of the next century and maybe the next civilization. So where does it leave us? We have taken the power of stars and tried to trap it in magnetic rings. We have battled with temperatures hotter than the sun's. We have spent decades designing machines that barely fit inside buildings. Will we get there? Probably. Will it be easy? Definitely not.